Hello and welcome to the next video in the Unix induction series. What we're going to be doing now is discussing and going through Unix file system permissions. So again, as always, we're going to open up the world's best program, terminal, and make it full screen. Whoops, just open two. Let me just close one and make it full screen. And again, just zoom in just so it's a little bit easier to see. And I'm going to run pwd and ls just to see where we are and what's in the folder. Always good practice. So now I'm going to make directory, just create a new folder, and I call that permissions. I go into that folder, and again pwd so you know where I am. The next step, and this is important just so we have something to compare with, is to create two empty files and two empty folders. Files and folders can sometimes show different permissions. So touch file 1, file 2, just as we learned from previous tutorials, and make directory dir1, dir2. So now when I run ls, we can see dir1, dir2, file 1, file 2. This is just some base so that we have some files that we can look at permissions and work with. The next thing I'm going to do is just clean up my terminal a little bit, just so you've got an easier workspace. So I'm going to use the clear command. Everything's still here, it's just being moved up a bit. So what I'm going to do now is I'm going to use the ls command, except I'm going to do one thing a little bit differently. Using the manual, just to show you, if I use ls, I'm going to scroll down until I get to, one sec, keep scrolling. Here. -L. -L is use a long listing format. In addition to using a long listing format, this format will show us things including permission information. So what I'm going to do here is ls-l, and what we see here is a little bit of a different screen when compared with ls, which just has the name of the file or folder. We get more information about the file and folder. So what we have here is the permissions, which I'll be coming back to in a moment and is the focus of this tutorial, the owner and the group. So this is the owner of the file or folder, which is induction, and the group the file or folder belongs to, and the date modified, or the date created, as well as the time. And then we've got dir1 and dir2, file 1, file 2. So the first thing, and for this entire video, we are going to be focused on this section. Do not have to worry about the rest, as this is the permission section of the information. So the first thing I want to point out is this first flag here, the D. You may notice that the D is only set for directory. This way we know that dir1 and dir2 are definitely directories based on that first option. If you look, when you compare and contrast that with a file's permissions, you can see that the first section is a dash, implying that it is not set or empty, and this means that it is simply not a directory, it is a file. So to explain file permissions, what I'm going to do is I'm going to use one of the text editors learnt in the previous video. This will simply give you something to look at while I talk, as opposed to using both the auditory and the visual to help you, assist you in learning permissions. So I'm going to go vim and type in permissions, and here I'm just going to use this as an editor. So in Unix, permissions can be broken down into four main sections. You've got the first section. I'm going to just draw this out now. So you've got the first section up here, which is your directory. So if the first flag is set, i.e. this first option is either a hyphen or a D. If it's a D, it's a directory. If it's a hyphen, it's not set. In this next section, this is the user permissions. In this section here, it's going to be group. And this section here is going to be other. And this will just give us a good foundation. Now I'm going to save that. I'll come back to that in a moment. I know this might seem a bit confusing. Permissions can be a little bit complex, but it's good to understand them. So using ls-l again, all I've done is simply take this section here and put it into the permissions file as a reference. So if I go back to the permissions file, what we can see here is I've taken those 10 either hyphens or digits or characters, and I've simply spaced it out and grouped that by directory, which is the first one, user, which is the next 3, group, which is the next 3, and other, which is the final 3. So of the sections user, group, and other, there are different flags that can be set. The first one is known as read. The next one is known as write. And the final one is known as execute. So for the sections user, group, and other, what you'll notice is that there'll either be an R in the first character if the user has read permissions, a write in the second section if the user has write permissions, and an execute in the final section if the user has the permission to run this file or folder as a program. And the same is said for group. Group can have read permissions. If that's set, if that's an R, or if it's a hyphen, it means the group does not have read permissions. If the second character is a W, it means the group has write permissions. If not set, it means the group does not have write permissions. And the final one is an X, again implying that the group can have execute or write permissions. And other is exactly the same. So the user, and we'll go back out of this in a sec, the user is listed here. And so what we can see with the file directory 1 is the user has the ability to read, write, and execute. The group, which is listed here, has the ability to read, but not write, but can execute. And other is classed by anyone who is neither the owner or a member of that group. So if they don't belong to the first two categories, they are classed as other. So the last one is other, which means if I am not the owner nor a member of that group, I can only read or execute the file. When we look at the file permissions, we can see that the owner can read and write, but can't execute. The group can read, but can't write or execute. And the other can read, but can't write or execute. So that's a bit of the basis of how permissions work. Again, just to reiterate, I'm going to go through the whole lot, and you may think, oh, I'm saying this a bit much, but again, it's just to help you remember, and hopefully my voice will be stuck there for a while, reiterating the same thing. So whenever you look at permissions, you immediately go, all right, the user has which read, write, or execute, the group has read, write, or execute, or the other has read, write, or execute. So the next thing we're going to look at is how to change permissions. So this is a bit of background information so far, explaining how permissions are structured and how to use them. But what we're going to do next is look at how to change them. So there are two ways to change permissions on a file or folder. The first way, I'll put up here, so change permissions. I'll just make this a bit easier to see. And so when we go in here, first way is going to be known as the graphical way. It's not graphical in the sense of a graphical user interface. It's graphical in the sense of it provides something which is associated with the terms user, group, and other. So, for example, to change permissions, we would use the command chmod or changemod. Chmod, and then what we would do here is either say which object, so the user, the group, or other, so let's assume user, and then we say plus or minus, plus to add or minus to remove. So for example, user plus read, and then the file name. Or chmod, group minus, so remove permissions, write, file name. So what we can see here is the first example again, chmod u, which is u for user, plus r for read, will give this file read permissions. And in the second example, g minus w will remove write for this file from group. So the group will no longer have write permissions. And these can all be in conjunction with each other. So for example, chmod u plus read, write, execute, and the file name, full access for user, and then chmod g minus read, write, execute, file name, no access for group. And I'll show you a couple of examples in terminal just so you get an idea. So let's do ls-l and then chmod u, I'll do group plus read, write, execute on file 1. Then if I do ls-l, we can see that file 1 for the group now has read, write, execute. And if I change this command by simply making this a minus, we can see that for file 1 now has no permissions for read, write, or execute. So that means any user who is a member of the group induction can no longer read, write, or execute, or really interact with this file. That's a bit about permission management the graphical way. So if we go back here, again, by using the objects, user, group, or other, and then specifying which permissions we want, we can add or remove. This is a bit easier at first, as it provides, again, a simpler way of remembering what user, group, and other are, and a simpler way of manipulating permissions. The problem with this is that it implies adding or removing. The better way, or at least I believe the better way, is to give absolute permissions. So instead of saying I want to add read or remove read, what I do is I tell it what the permissions for user, group, and other should be as a decimal number. So what I'm going to do here, and this will be the binary way. What we're going to do now is we're going to quickly learn binary. Don't stress, it's not going to be too in-depth. It's just to give you a little bit of idea of how the binary way works. So what we can see here is if I go and say that, and I'll put, what I'm going to have here is decimal on the left and binary on the right. So decimal is something you should hopefully be pretty used to. That's what you've been doing in math, numbers 0 to 9, and it's what's used in everyday accounting and mathematics and economics. Binary is more of a foundation for computing. It treats everything as a true or false, a 0 or 1, a yes or no. It is simply saying something can either be set or not set. Everything is either black or white, yes or no. It is 0 or 1, and binary is simply saying it's a base 2, or it only has 2 digits, 0 or 1. So what I'm going to do here is a quick little chart to give us an idea. So 0 in decimal is 0 in binary. So it's a bit easy to start off with. 1 in decimal is 1 in binary. 2 in decimal, which I'm going to write out here, is 1, 0. And this is where it might get a little bit confusing. What you can see here is with binary, is 1 set no, is 1 set yes. So when 1 is not set, it's 0. When 1 is set, it's 1. With this example here, is 1 set no, is 2 set yes. And that's where you get 2 from. So you may have already picked up the pattern here. If not, don't stress. It takes a little bit of time to get used to. So 3, what we would do here is 1 set, yes, is 2 set, yes, and that makes 3. 1 plus 2 is 3. So with 4, what we're going to see again is 1, 0, 0. With 5, what we're going to see is 1, 0, 1. With 6, 1, 1, 1, 0. And with 7, and what you may notice here is if you look at binary, there's a very, very good pattern here. And what we can see is with 7, we can see that there are 3 unique bits being set. And that's something I want you to remember just for a couple minutes. 7, 3 different bits are being set, and this will keep it handy for learning the binary way to manipulating file permissions. So when it comes to file permissions with the binary way, is each option is assigned a number. So we have our read, write, execute as discussed before. In this example, read is assigned to 4, write is assigned to 2, and execute is assigned to 1. So you remember how I said before, with 7 there are 3 unique bits being set, a 4-bit, a 2-bit, and a 1-bit. This is how this lines up. Read is equal to 4, write is equal to 2, and execute is equal to 1. So what happens here, and what I'm going to do, is that we've got, for example, if I was to use the command, again it's chmod, but instead of u plus x or u minus x, I'm going to do a number. So for example, 755, and then the file name. So what is this actually saying? Well, 7, if we go back to this chart here, 7 is 4 plus 2 plus 1, which means that there is read, write, and execute. 5 is 4 plus 1, implying that it's just read and execute. So 5 again is read and execute. So with this example, user has full access, group has read and execute, and other has read plus execute. So let's do a couple of examples. Let's do 644. What do you think 644 might be? So if we go and use the same logic again, 6 is 4 plus 2, so that's user has the ability to read plus write, but no execute, and the group has the ability to read, and other has the ability to read. So what we're simply doing when using the decimal way is we're using the concept of binary, and we're adding up all the numbers, and that defines our access. So 7 is full access, as implying that 4 plus 2 plus 1 is 7. 5 is read and write, read and execute, sorry, implying 4 plus 1. And read is simply just 4. So if you want to just write access, you would have 2. If you want to just execute, you would have just 1. So here are two different methods for working with permissions. Again, the binary method is more absolute, so it's less add or remove, and it is the recommended way. But when you're getting started, as it is a new sort of concept, it is completely fine to use either the graphical or the binary. So what I'm going to do now is I'll save this, and I'm going to just display this on the screen, and I'm just going to scroll through it quite slowly, just to give you an idea of what we've covered so far. So again, directory, the different options, there'll be 10 total. If the directory bit is set, that'll be a D or nothing. If the read, write, or execute for each of the objects, if they're set, it will either be the letter or a dash if it's not set. And then we've got the graphical way, which is all about using the object's first character to add or remove, and the binary way, which is based on binary. So just another example, if I use ls-l chmod 755 on file 2, we can see that file 2 now has read, write, execute, read and execute, and read and execute. So this concludes file permissions. I hope you've learned a lot from this video. And again, as always, do not stress if you don't take it in the first time. These concepts are quite complex, and it may take a day or two, or even watching the video 2 or 3 times to fully understand them. So take all the time you need, and remember to work at a pace that best suits you, not a pace that's set by this video. I hope you have a good day, and I'll hopefully